I hope he doesn't like get mad. It's just I really want him to solve this problem for us.
I know, it's okay. I don't think he'll get mad. Everybody wants him to get mad.
Oh, I see. Y'all are getting ahead. Everyone take out your notes. Don't forget to date them. It's crucial to date your notes, especially if you move on to college. Who has a question on this problem?
I do. I didn't get number 62. I had a problem when I got to the derivative.
Alright, let me walk you guys through this. This function is rather peculiar because it's a radical function. It's radical because this is, you don't have to write this, it's the same thing as writing. You all see that, right?
Yeah.
Alright. So what she did is, she found the domain is equal to all real numbers. How do you find this? Tell the class.
Because
when the exponent is an odd number, so exactly when it's like that, when it's 3, then the answer is always going to be a negative. And then, for example, for a 2, then it could be a positive or a negative. If it was like just squared.
You guys all get that, right?
Yeah.
Alright. Range, we don't know yet because of the prop. We'll find out later. Intercepts, she made that cheesy little graph that I like. 0, she found this. Perfect. She has done everything right so far, even plotted the points. Good. She put it equal to 0 to find the x values for y. And she found when she plugged in 0 for x to get -2. You guys are all caught up so far, right?
Yeah, we're good.
Alright. Next, she found the first derivative using product rule. She did the first times derivative of the second using big power rule and beta chain rule, plus the second times derivative of the first, big power rule and beta chain rule. And she got this. What do we need from here now?
The greatest common denominator.
Good, common denominator, perfect. Color coded. My students have found bringing colored pencils to the test has worked. It's worked for them. Whatever works for you to pass your test, you do it. What do we need here? We need
an x minus 2 to the 2/3.
And here?
And x plus 1 to the 1/3 and to the top.
Is whatever you do at the bottom, you do at the top.
Good. Who's saying that?
Everybody.
Alright. Are you good here?
Yeah.
Weak students in algebra are going to have to take more steps, but I'm pressed for time, so I'm just going to simplify this. You guys see how they combine like terms? 2/3 and 1/3, you add them. Equals 1. You guys all see that, right? Equals 1. They combined all the like terms. If you're weak in algebra, it's not my fault. If your prior teachers didn't teach you as well as I taught my kids in Dash, I'm sorry. Next, we're going to set f prime of x equal to 0 or undefined. So what do we do?
You're going to put 0 equals x minus 1.
Because in order for this to equal 0, only the numerator has to equal 0.
Yeah.
So we're going to add the 1 to the other side. 1 equals x. Undefined, the denominator has to equal 0. And we're going to do the same thing as we did earlier, in here. So 0 equals, throw that to the other side.
X plus 1. And then you
Minus a 1, negative 1 equals
Yeah.
x. Right? You got that?
Yeah.
Throw that over to the other side, equals negative minus 2. Simplify that garbage, 2 equals x. These are the critical numbers, you plug it into the original function, and then you find the points. So we're going to get 1, negative 1, and 2. When you plug in 1, what do you get?
Negative 1.58.
Negative 1.58.
0. And then 0.
So we're going to go ahead and plot these numbers on the graph. They're already there. All right. From the first derivative, we found our critical numbers. With the critical numbers, we found intervals for the first derivative test. Increasing, decreasing, no windshield wipers, right? So we're going to go pick a number from -1 to -infinity. Let's pick -10. This means it's increasing. The negatives cancel, making it increasing. The next one, from -1 to 1, we're going to plug in 0 and we're going to get negative. There is a change from increasing to decreasing, a big change. This is important. Alright. Important. It deserves 3 stars. This change is a relative maximum. You all get that, right? Then we're going to plug in from 1 to -2. We're going to plug in 1.5, making it increasing. There is another change here, from decreasing to increasing. This is a change, but it's going to be our relative minimum. And then we're going to plug in +10, and we're going to get an increasing function. So now we've kind of get a little bit of a general form of our function. It's going to come from decreasing, it's going to increase like that. It's going to start from the bottom and increase to this point. And because we know that this point is not differentiable, and it's going to be a sharp point because it has an undefined slope, we know a general form, so it's going to come up like this. Sharp point. That's a line for a sharp point, right? The point's going to come down, and this is the relative minimum. Up again here, because this point also has an undefined slope. So we'll practice more with these later on in the course. Mr. Buzzin really hasn't gone over too many problems like this, but let's do the second derivative to find a better shape and the exact shape of our